We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India.
Hello and namaskar to all the viewers. Today we are going to learn analysis of WRC beam having under reinforced section. First of all, let me clear what does analysis of beam means. Analysis of beam means dimensions of the beam and the properties of the material are given, and we need to find the moment carrying capacity of the beam. I have written one example here. Let's first read. A reinforced concrete section 300 mm wide and 600 mm deep. Let me draw the cross section 600 mm and 300 mm. Width of the beam is 300 mm and 600 mm deep overall depth. Overall depth is 600 mm. Is reinforced with tensile and compression reinforcement 4 number 25 mm dia and 4 number 16 mm dia at an effective cover 50 mm on both sides. Means effective cover on both sides are 50 mm respectively. It means 4 number 25 mm dia are in tensile zone and 4 number 16 mm dia are in compression zone. Four number 25 dia for number 16 dia. This is ASC and this is AST. Effective cover on both sides. In tension zone, it is called E50 mm, and in compression zone, it is called D dash, and D dash is also 50 mm. So B equal to 300 mm, capital D equal to 600 mm. We need to find small d means effective depth. Effective depth means what? Effective depth means overall depth minus E. Overall depth is 600 mm minus effective cover is 50. So in this way, we get effective depth 550 mm. Now, in tension zone, 4 number 25 mm dia bars are used. 4 number 25 dia, it means 4 into pi by 4, 25 square. Square means 1963.50 mm square, and ASC 4 number 16 dia 4 into pi by 4 16 square. So we get 5 into 16 square 804.25 mm square. E is equal to 50 mm and D dash is also 50 mm. So what we need to find we need to find the moment of resistance of the beam. So moment of resistance MR of WRC beam equation is C1Z1 plus C2Z2. MR is equal to C1Z1 plus C2Z2. We know C1 0.36 FCK B into XU and Z1 D minus 0.42 XU plus C2 FSC into ASC and Z2 D minus D dash. It means in this equation, unknown values we need to find first. See, XU in this equation, first unknown is XU and the second unknown is FSC. If we find the XU and FSC, then we can easily calculate the moment of resistance of the beam. So in this case, first we find the value of FSC. To find FSC. Method of finding the FSC basically are two. I mean, there are two methods in which we can find the value of FSC. FSC is stress in steel in compression zone. First method is using handbook and the second method is using the IS 456. First, let's find using handbook. In handbook, page number 30, table F is given. For that, first of all, we need to find the ratio of D dash by D. D dash, it is given 50 and the effective depth is 550. When we do this, 50 upon 550, we get 0.09, right? And from table F, we get the value of FSC directly, and for grade FE 415353 Newton per mm square. In table F, value is given for 0.10, but 0.09 is nearly equal to 0.10. That's why we have taken the value of 0.10 as 353 Newton per mm square. In handbook, it is clearly mentioned that table F is used only for FE 415 and FE 500 grade of steel. If steel grade is 250, then this value is comes 0.87 F5. From where 0.87 F5 comes, we will see in IS 456 later. Now, to find FSC using IS 456, now we are going to find value of FSC using the IS 456. For using IS 456 to find the FSC, first of all, you need to find the XU max, and we know that IS 456 page number 70, the value of XU max by D are given. For FE 415 grade, what will be the value of XU max by D? So it will be 0.48. That's why we get XU max equal to 0.48 into D is equal to 0.48 into small d is 550. So in this way, we get the value of XU max 0.48 into 550, 264 mm, right? So we get value of XU max is equal to 264. After finding the value of Axiomax from page number 96. You need to find the strain, and the value is given 0.0035 Axiomax by D dash upon Axiomax is equal to Axiomax is 264 minus D dash is 50 and Axiomax is 264. 264. 0.0035. So we get 2.8 into 10⁻⁻³ or you can say 0.0028. So in this way, we have found out the value of strain 0.0028. Now, using this strain value, we have to find the value of stress which is given in IS 456 page number 70. Now I am doing this. Alright. From IS 456 page number 70 graph 23.8. Okay. In this graph, stress versus strain values are given. Means it's look like this. Okay. Vertical is stress and horizontal is strain. And our value comes near to 0.03. Our value of strain is 0.0028 and the value of strain in IS 456 is given for 0.003. So we take nearly equal to this. First, what you need to do is you need to draw the parallel line with this line, and this parallel line where it intersects this Fy upon 1.15 line, corresponding to that intersecting line, you have to find the stress value at vertical. So in our case, it comes FSC equal to 0.85 Fy. So in this way, we get 0.85 into 415 is equal to 0.85 into 415. So we get 352.75, which is nearly equal to 353 Newton per Fs mm square. See, using handbook, value comes 353, and using IS, also value comes 353. Why I have found out using IS 456? Because in some colleges, handbook does not permit. That's why in that case, you should know how to calculate the value of FSC using IS 456. Again, I repeat, for finding FSC using IS 456, first you need to find the Axiomax which is given in IS 456 page number 70. Then you need to find strain value. The equation of strain value is given in IS 456 page number 96. And the equation is 0.0035 bracket Axiomax minus D dash upon Axiomax. Putting all the values, we get the value of strain is equal to 0.0028. Now, with respect to this strain value, From page number 70, graph 23A, you have to find the FSC. So graph is about stress versus strain. In graph, value corresponding to strain 0.003 is given. Our strain value has come 0.0028. So it will come almost near to 0.003. So what you need to do that, draw parallel line with this line from our corresponding strain, and that parallel line where intersect with Fy upon 1.1 line corresponding to that straight line, you have to find the stress value. When you look at the graph 23A, you will find the stress value 0.85 Fy, and putting the value of Fy, you will get the value of FSC. So in this way, using IS 456, we can get the value of FSC. Now, in IS 456, page number 70, in 23B, from graph 23B, the graph is given like this. This is for Fy upon 1.15. See, graph 23A is for Fe 415 and 500 grade steel, and graph 23B is for Fe 250, means mild steel, grade steel is given in graph 23.8. When you observe this graph, you will realize there will be no value of strain here. Yes, there will be no value of stress here. Same, there will be no value written in the vertical face. What does that mean? It means that for any value of strain, yes, for any value of strain, we will get the stress value equal to Fy upon 1.15. Now, Fy upon 1.15 means what? 1 divided by 1.15, it is equal to 0.87 upon Fy. Means whatever value of strain, when we draw the parallel line, we will get the value 0.87 Fy. That's why in handbook, page number 13, it is clearly written for Fe 250 grade of steel, the value of FSC will be 0.87 Fy. Because handbook is made using the IS 456. So whatever they have written in handbook, they have used the help of IS 456, right? So in this way, we get FSC. Now, let's move. So, FSC we get 353. So, in analysis of WRC beam, first you need to find the value of FSC. Then, the next is to find the value of XU. Yes, the depth of neutral axis. So how we calculate the depth of neutral axis? Equating total compression is equal to total tension. So in WRC beam, total compression is equal to total tension. In WRC beam, total compression force is C1 plus C2 and the total tension is T. C1, I have already explained. C1 is what? Total compression force in singly RC balance section. And what is the C2? Total compression force in auxiliary section. Now, write the value of C1, 0.36 FCK B into XU plus C2 FSC into ASC is equal to T means 0.87 FY AST. Now put all the values 0.36 FCK, it is given 20, width of the beam is 300 mm and our interest is XU plus FSC. We have already find out 353. And what about ASC? ASC is given 804.25 is equal to 0.87. FY is given 415 and AST is given 1963.50. That's why in this way, when we calculate this, 0.87 into 415 into 1963.50 minus 353 into 804.25 divided by 0.36 into 20 into 300, we get the value of XUS 196.77 mm. Right? What you do is first calculate this, then whatever value comes, this minus this, then that value divided by, you do this, in this way you get the value of XU. Now the next step is to find XU max, right? So in this example, to find the value of FSC, we have already calculated XU max, right? And what was that value? XU max by D equal to 0.48. Therefore, XU max equal to 0.40 into D equal to 0.48 into 550. So we get 0.48 into 550, 264 mm. Right? XU is 196.77 and the value of XU max is 264. So here XU is less than XU max. When XU is less than XU max, it means that our section is under reinforced section, right? So first what we did, we found the value of FSC, then we have found out the value of XU, then XU max, then equate XU and then compare the value of XU and XU max. On the basis of that, you will get the section is whether URS or ORS, right? In our case, the section has come under reinforced section. Then finally, to find MR, so equation of moment of resistance is C1Z1 plus C2Z2. C1 is what? 0.36 FCK B into XU into Z1 means D minus 0.42 XU plus C2 FSC into ASC into Z2 D minus D dash. Putting all the values, FCK is 20, B is 300, now here XU. In case of URS, put the value of XU. And if our section came ORS, then put the value of XU max instead of XU. In our case, our section has come URS, that's why in equation we have written XU. So what is the value of XU? 196.77 into our effective depth is 550 minus 0.42 into 196.77 plus FSC 353 And what about ASC 804.25 into what about D 550 and 50? Now calculate this. So if you want to calculate in one step, so just first counts and the second counts, and here one counts and another counts. You have to do here three counts, right? 196.77, 1, 2, and 3. So let's calculate 0.36 into 20 into 300 into 196.77 into bracket 550 minus another counts 0.42 into 196.77, one count, one bracket, second bracket, and third bracket, plus bracket 353 into 804.25 into, you can directly write down 550 minus 50, it comes 500 into 500 bracket over. So in this way, we get 340.58 into 10⁶ Newton into meter, and when you convert this in kilonewton into meter, you will get 340.58 kilonewton into meter. Right? So in this way, we can calculate the moment of resistance of the WRC beam. Now, let me summarize this example. To find the moment of resistance of the beam, first you need to find value of FSC. FSC you can find two ways, means one option is using handbook and the second option is IS 456. Then to find the value of XU in WRC beam, for finding the XU, you have to equate total compression is equal to total tension, right? In the case of singly RC beam, the equation of XU is directly given in IS 456, but in WRC beam, you have to use the equation total compression is equal to total tension, and using that equation, you will get the value of XU. Then, to find the value of XU max, then you have to compare the value of XU with XU max. On the basis of that, if XU less than URS, if XU greater than, it means it is ORS. Finally, moment of resistance is equal to C1Z1 plus C2Z2. In this equation, if section is URS, then put the value of XU, and if the section is ORS, put the value of XU max in the equation of MR. So, in this way, we can find the moment of resistance of the WRC beam having under reinforced section. So, today I conclude this session here. Thank you.